Assalamu alaikum wa rahmatullahi wa barakatuh, and peace be upon you all. My name is Khamis Minshawi, and I'm partnered with Manaz Riaz. Our project title is called Real-Time American Sign Language Recognition System, and it is supervised by Dr. Norlia. Our project ID is 713D. This is our poster. So we're going to be explaining on the contents in this poster. So first of all, in today's world, there has been a rapid growth in the population in the recent decades. And with how the nature of the world works, it is inevitable that more problems will arise with the increase of the population. And one of those problems is disabled people. To be more specific, deaf and hearing/speaking impaired individuals. According to the WHO, it is estimated that by 2050, over 700 million people, or 1 in every 10 people, will have disabling hearing loss. However, fortunately, there have been many technological advances that can assist the individuals while using the internet, or whenever they are out and about doing their daily activities. Deep learning and computer vision may also be used to help with the cause. This can be very useful for deaf and dumb people in communicating with others, since sign language is not something that everybody knows. In this project, we are going to build a sign detector that recognizes numbers from 1 to 10 and may readily be expanded to cover a large array of other signs and hand movements, including the alphabets. So moving on to the problem statement. So over here, the first point is sign language requires a lot of training to be understood, and so not everyone will be able to understand what the gestures really actually mean. Second point is there is still a communication barrier between the hearing/speaking impaired and the rest of the world. And the third point, last but not least, to help bridge this communication barrier, our proposed system will be able to translate basic sign gestures into readable English words. For the significance of this project's goal is to assist the deaf and the disabled people in their everyday lives, such as in online classes, could be meetings, and even video calls. The proposed system will have various amounts of information stored in advance, as well as real-time data collected from the sign detectors when utilized. It will facilitate communication between those who are deaf or hard to hear and other individuals during online and face-to-face interactions. So moving on to the objectives. First and foremost, this project aims to create a system that will be able to bridge the communication gap between the hearing/speaking impaired individuals and the rest of society. The second objective is to assist hearing/speaking impaired individuals by helping them effectively communicate with people face-to-face and online through video calls and meetings. And last but not least, to build a system that can interpret sign language gestures using machine learning and image processing. So that's all from me. Brother Manas is going to carry on from here.
I'm Manaz Riaz, matric number 1818665, and I'm going to talk about the methodology of our project. There are three main stages in the process of translating a sign gesture into readable English text. The first stage is image capture. Before the image can be pre-processed and then processed by a machine learning algorithm, the image containing the sign gesture must first be captured in real time by the camera. So the user will first have to signal a hand gesture to the camera, which can be a built-in laptop webcam or can also be an external webcam, and then the image will be captured. For good results, a high-definition camera must be used, and you must make sure that you have good lighting conditions. before the image is captured. The next stage is image pre-processing. Before the image can be processed by a machine learning algorithm, several adjustments need to be done to the image, like cropping, filtering, and adjusting contrast and brightness. In addition, machine learning algorithms cannot directly work on full-color RGB images, so the RGB image must first be converted into a binary image. Also, unwanted parts of the image, like the background surrounding the hand gesture, needs to be removed. The last stage is feature extraction. After the image has been captured and then processed, the image is now ready for feature extraction. This can be done by using machine learning algorithms like CNN or SVM. This project is going to be coded in Python, and for image capture, we're going to be using OpenCV. OpenCV is a massive open source Python library that is mainly used for real-time computer vision projects. For image pre-processing, we're going to be using Keras and TensorFlow. These are both open source Python libraries that can be used for image pre-processing. For example, Keras can be used to convert an RGB image into a binary image. For feature extraction, we're going to be using machine learning. So deep learning algorithms like random forest or SVM can be used here. This is the expected output of our system. So the user is going to be first signaling a hand gesture, for example this one right here, which looks like a clenched fist with a thumb pointing upwards, and then the image is going to be captured, processed, pre-processed, and then processed by an ML algorithm, and then the system will finally recognize this gesture as the letter A, and then the letter A will appear as a subtitle at the bottom of the screen. The same for S and L, and the system will also work to translate full English words as well. Thank you.